Hi, my name is Asha, and today I would like to present a paper, Bayesian preference, inference, and dialogue. This work has been done in collaboration with Ella Eisenman and Martin Booth at the University of Tübingen. Our goal is to model the process of inferring priors in the Rational Speech Act framework. We compare the predictions of our models to the behavioral data we obtain in online experiments. Finally, we aim at connecting two rich fields of research. On the one hand, linguistic literature on ambiguity resolution, and on the other hand, computational approaches to modeling how latent variables are inferred. Different aspects of this work have been previously discussed in the literature. Our focus today is on modeling prior inference of the listener in a multi-trial reference game. In the course of an experiment, the subject has first to choose an utterance that selects one of the objects in such a way that she could learn the preferences of a character that you see on the right. Here, for example, we need to infer Megan's preferences for colors. If we select an utterance like circle, for example, then only one of the objects can be chosen, and Megan's choice will be uninformative. Picking square, on the other hand, gives us two possible references, a blue dotted square and a green solid square. If Megan chooses the object in the middle, we can infer that she prefers blue objects over green objects and thus drag the slider for blue to the right. And the fact that she doesn't like green objects makes us drag the slider for green to the left. Notice that we haven't observed any red objects here, so we cannot update our posterior of the preferences, and we keep the slider in the middle. The modeling part mimics the process that the human subjects follow in the experiment. It starts with a flat prior on trial 1, equally distributing the probability mass between blue, red, and green. Then, having observed an object choice, we assign a probability of 1 to the fact that Megan likes blue objects and a probability of 0 to the fact that she likes green objects. For red, since we don't see any red objects, we keep that cell unfilled. Further, we multiply the observed values by priors and also take into account the fact that some of the values were not present in the scene. In that case, we pass their priors unchanged and then distribute the remaining probability mass between the options that were present according to the choices that were made in the experiment. On trial 2, we start with the posteriors from the first trial and now take them as priors and see a new selection of objects and a new choice of utterances, but importantly, the listener remains the same. So the same character stays for all the 4 trials in the block. We further parameterize the model by adding a free parameter for softness of the judgments. If judgments are hard and subjects use the far ends of the scale, picking 0 for feature values that the subject doesn't like, or 1 for feature values that the subject in a trial likes, we say that the value of the common parameter is 0. However, if the judgments of the participants are more subtle, then we can estimate the parameter as having a higher value than 0. In these plots, we demonstrate data from globally optimized model that where the calculations were done in an iterative versus non-iterative fashion. And we see that the plot on the left, the iterative model captures a larger proportion of variance in the data compared to a non-iterative model, demonstrating a Bayesian update of feature preferences. Finally, we can look at the role of ambiguity in creating the situation of successful learning. We see that the best learning success happens if all of the utterances in a block were ambiguous. There were 4 utterances in the block maximally. And this holds true both for the human data and for the model. To conclude, we see that humans update their prior preferences in an approximately Bayesian fashion. We noticed that ambiguity resolution creates an opportunity for learners to learn something about the listener. We further discussed the role of inferring listener preferences for the success of communication and social interactions more broadly. We then interpret our findings within the predictive mind perspective on human cognition. Thank you for your attention.